This is a quick lesson on properties of matter I wanted to cover as we head into the unit on fluids. The first is a review of mass density. We'll be working with mass densities as we look at fluids. Mass density is represented by the Greek letter rho, and it is the mass per unit volume. It has SI units of kilograms per meter cubed, but often you will see it given in grams per centimeter cubed. And you can see over here in the chart that there are varying mass densities depending on the substance. Heavier, denser materials have higher mass densities. Remember, at any time, if you need a mass density, you can look it up in a chart in the book or on the internet. A related concept is the specific gravity or relative density of substances. And what the specific gravity represents is a ratio of density of an object to a fluid. So oftentimes this is used to look at whether things will float in a fluid. And what you do is you take the density of the object and you divide by the density of the fluid that the object is in. And this is a dimensionless quantity. You can see that if I have a density over the density, the units cancel, so it's dimensionless. So when I look at this ratio, if it's less than 1, then the object will float in the fluid, and if it's greater than 1, it will sink in the fluid. So this is like a relative number, a relative value. You may see this and it will come up later in some units. As we define fluids and as we head towards thermodynamics, I wanted to talk about the phases of matter. The phases of matter are solid, liquid, gas, and plasma. So I wanted to go over these with you. The distinguishing differences among the phases of matter is the distance between the molecules and thus the types and frequencies of interactions between those molecules and the container walls that substance may be in. So when you look at solids, the molecules are very close together. They're actually modeled to be attached to one another. When you look at liquids, the molecules are not attached to one another and they flow past one another. In gases, they are definitely not attached to one another and very spread apart. And then plasma, the definition of plasma is that the ions are separated. So like if you have water, if this is H2O, the plasma would separate into the oxygen ions and the hydrogen ions. So H plus and O2 minus. And so that would be the plasma for water. The phases of matter and their molecules thus have different qualities that we look at. I just talked about molecule spacing, how close they are, whether they're still attractive or if they're really far apart and just randomly bumping into one another. The molecule movement can also be distinguishing. In the other 3 phases, the liquid, the gas, and the plasma, all of the molecules flow past one another. And this is actually the distinguishing feature of a fluid. That is what we're going to define to be a fluid. So yes, liquids are fluids, but gas is also a fluid and plasma is also a fluid based on this quality of flowing. There's also molecule speed. With stationary solids, they're stationary. With a liquid, there's medium speed. The molecules will bounce around in a liquid. And in air, they're very fast. The air molecules will bounce around. And in plasma, they're very, very fast. Very, very fast. Very hot, and the molecules in a plasma are very fast. The 4 different phases also respond differently to stress. When you think about a solid, it resists stress and it also restores back into its same original formation. Liquids resist being stressed, but they will deform, right? They will, if I push on a liquid, it will move out of the way, whereas a solid, it will resist my hand. Gas and plasma compress. When you put stress on a gas or a plasma, when you mush on it, it will compress. Finally, when you look at how they respond in a container, because solids are stationary, they remain in one place. Liquids are also more confined to gravity and being pulled down by gravity, and they will take on the shape of their container, but they will not escape their container. Whereas gas and plasma will escape their container, and that's a lot because they're actually moving very fast. They can move out of that container because of it. So when I look more specifically at fluids, the distinguishing property of fluids is that they experience flow in response to shearing forces, or what I think of more as pressure differences. This depends on viscosity. So for instance, you don't think of air as a fluid. But if you were an airplane and moved very fast in the air, it would feel like a fluid. If you were a spaceship and flying out into space, there would be a region where you were affected more by the atmosphere at that speed. And then farther out, you would get into more of the vacuum of space and not be affected by air at all. So the viscosity and the speed make a difference when you're considering flow. Again, they conform to the shape of the container. So if you put air in a container, it conforms to that shape. If I put a solid in the container, the solid will stay in its original shape. So what we're seeing is plasma, gas, and liquid are all defined to be fluids. In the next couple of lessons, we're going to look at fluid statics, which is fluids at rest, and then also have a lesson on fluid dynamics, which is fluids in motion. Before we do that, I wanted to wrap up with one more slide here, talking about a review of the fundamental principles that you should know and have mastery over as you move from General Physics 1 into General Physics 2. The fundamental principles that you learned in General Physics 1 was the basics of motion, kinematics, definition of displacement, velocity, acceleration, force, etc. The laws of motion, which is Newtonian laws of motion, the first law, the second law, the third law, including circular motion with centripetal acceleration. We looked at transformations of energy and work, and then also conservation of momentum, not only just linearly, but also angularly. These are the fundamental principles of physics that you will find in all topics of physics that you study. Physics follows one of these 3 or 4 principles. I will also keep in mind that there are conservation laws that the cosmos simply obeys, and we will observe them as we move forward. The first one you will see more frequently with the material is conservation of energy or mass. Remember, Einstein said that mass is energy, so it can't just go anywhere. We're going to keep that in mind. We're going to look at charge in General Physics 3 and conservation of momentum in General Physics 3, but these are all important principles as we move forward.